In this video, we will be talking about linear momentum. So, what is linear momentum? It's in a very short explanation sense. It's sort of a number that tells you how hard it is to stop something, and also the direction and velocity of where something is going. But I already hinted at the formula for calculating linear momentum, but the formula for calculating linear momentum is simply mass times velocity. And since you're multiplying a scalar by a vector, the result should be also a vector. Therefore, momentum is a vector. Now, since you're multiplying mass by velocity, the unit for mass is kilos, and the unit for velocity is meters per second. So if you multiply these two units together, like so, you get a unit that sort of looks like kilos meters over seconds. So this is the unit for momentum. Now, let's talk about impulse. So, impulse. What is impulse? Well, impulse, very, very closely tied to momentum. It's simply the change in momentum. And impulse is represented by J. And you can calculate impulse by either calculating the final momentum and subtracting it with the initial momentum. And as always, that is going to be change in momentum. But you can also multiply a constant force by your change in time. And then you can get your impulse as well, or your change in momentum. But for varied forces, you can use an integral of your force function with respect to time. And this also equals impulse. So that's really all you need to know about impulse. Let's get into some problems related to linear momentum specifically. Now, on a side note, linear momentum, I'm specifically stating linear momentum because there's something called angular momentum as well. And that's to the extent of the knowledge I know, but angular momentum, something completely different. Don't confuse those two. So this problem is simple. It just has you interpret the problem and then just calculate the momentum. So remember, momentum is a vector value of mass times velocity. So try to do this yourself. Now that you've done it, let's mark down what we have in this problem. Well, we have a mass of 2,000 kilos for this car. We also have a constant velocity, which matters, by the way. A constant velocity of 10 meters per second due east, however. So if you have your little compass here, you will have north on the top, west to the right, east to the left, and south to the bottom. So east is kind of implying that we will have a negative velocity since you're traveling in the direction left, and usually left is associated with negative. So we have a negative 10 meters per second as our velocity. So all we need to do is multiply these two together, and then we can get a momentum of negative. So negative 10 times 2,000 is negative 20,000. But what's the unit for momentum? Well, the unit for momentum is just kg dot m over seconds. And the reason why this is the case is because the formula for momentum is mass times velocity. So if you multiply the units of mass and velocity, they combine to form kg times mass over seconds. So this problem is slightly different. We have to calculate the momentum, but this time it's not in one dimension. So our velocity has two dimensions, just like how any vector value has. So since velocity is a vector value and momentum is also a vector value, you can calculate, again, momentum is equal to mass times velocity. Maybe I should start erasing that equation every single time. But, okay, calculate the momentum in the system. Try to. Well, let me show you how to do it. Well, remember, momentum is equal to the mass times velocity. So all we do is multiply 75 kilos by this vector velocity in two dimensions. But remember, if you multiply a scalar value or just a constant number by actually not just a constant number, a scalar value is just a non-vectored value. So if you multiply a scalar value by some vector, you just need to distribute the 75 into each of these. And once you distribute the 75 into both of these numbers, you get 75 times -5, which is equal to -375. And when you multiply 75 by 2, you get 150. So this right here is our momentum. And again, momentums are vectors, so you should normally get something like this, anything past one dimension. You should get multiple values. So a neat thing about momentum is that you can calculate the momentum of a total system. And this is going to be important for you guys when looking at collisions, which, if you want to look at that, I have a video down in the description for my collisions video when I make it. So I'm going to make a video about law of conservation of momentum and collision. But back to the problem. You have a car here, and you have a mass, and you have its velocity. You have a truck, you have its mass, and you have its velocity. Well, the thing about this is that you can actually add the two vectors of the momentums of the cars and truck, and then you can get the total momentum of a system, which is important for using or for calculating things using the law of conservation of momentum. So I will introduce you guys to that that concept right now. So in order to calculate the momentum of the car, you just need to multiply the mass times velocity again. And again, we're multiplying a scalar by a vector. And once you multiply all this out, you get a momentum of 20,000 and 0. So let's calculate the momentum of the truck now. Again, mass times velocity, like so. And when you multiply everything out, you get 0 and -120,000 kilogram meters per second. So these are the two momentums of the car and the truck. Now, the reason why it's important to get them is because when you're studying for collisions, the overall momentum for most of these collisions will stay the same due to the law of conservation of momentum. So what do I mean by the overall momentum? Well, the overall momentum is just when you add the two momentums inside of the system together. Or three even, if there's three vehicles colliding. And then they end up on Instagram Reels. But we can add the momentums of the car and the truck together. So add these two vectors together. And once you add the two momentums together, you will get a total momentum of 20,000, -120,000. So if you're looking at the effects of, okay, I'm running out of space. So if you're looking at some effects of some collision or some interaction between these two vehicles, then the final momentum of the system and before and after must be the same. So again, I'll have a video on the conservation of momentum in the description for that to help you. But next problem, we're going to be talking about impulse. So let's say we have a car that weighs 2,000 kilos, maybe a Honda Civic, and we have a velocity of 25 meters per second. And we want to calculate the average force needed to stop the car in 5 seconds. So when you see something related to force, or average force, or varied force, doesn't matter, and you have a momentum problem, you normally would want to use impulse. Now, you can use kinetic energy and work for this, but in this problem, let's not do that. Let's focus on impulse. So first off, impulse is your change in momentum. So in order to find your impulse, you need to find your current momentum. So to find the current momentum, again, you need to multiply your mass times your velocity. So when you multiply 2,000 kilos by 25 meters per second, you get 50,000 kilogram meters per second, which is, again, the unit for momentum. So 50,000 is our momentum. And keep in mind right now, we're calculating this in one dimension, so your velocity only has one component, therefore we don't need to express it as a vector, or with the angled brackets at least. So we have this momentum, and we want to calculate the force needed to stop the car in 5 seconds. Well, our impulse must be just -50,000, and the reason why is because since we want the car to stop, the momentum therefore should be 0, because if the velocity is 0, then the momentum is 0. So we want our impulse to be -50,000 in order to change our momentum, or the momentum of our car, to 0. So this should be our impulse. Let's not write the vector on top. And since our impulse needs to be negative 50,000, we can set this equal to force times time, since that's how you calculate impulse. So force times change in time. But our change in time should be 5 seconds. So we can replace our change in time, delta t, with 5 seconds. And all we need to do is look at this equation here and then isolate force. So once you isolate force, you get an average force of negative 10,000 newtons, which is quite a lot to stop a car in 5 seconds. That's why most cars traveling at this speed cannot stop in 5 seconds. So do not tailgate people on the highway like some assholes that are tailgating me yesterday. But the reason why this is a negative also is because even though our velocity is in one dimension, we still need to take into account direction. So negative, make sure to keep the negative in mind, since the negative force indicates that you're going in the opposite direction of your velocity vector. So this problem is a little more sophisticated than the others, but it's then again related to impulse. So as always, I want you guys to try to solve the problem. Now that you have hopefully tried it, at least, calculate the final speed of a 110 kilo rugby player who's initially running at 8 meters per second, but collides head-on against a padded goalpost and experiences a backward force, so a force that goes in the opposite direction of his current momentum, for 5.5 times 10 to the power of negative 2 seconds. So 55 milliseconds, I think. Yes, that should be right. So let's write down all the information we have. We have a mass of the rugby player, 110 kilos, who's initially running at 8 meters per second. So this guy's definitely not a linebacker. He's running pretty fast. But collides head-on with the padded goalpost and experiences a backward force for this amount of force in this amount of time. So this immediately indicates impulse. Force times time is equal to impulse. So we can set up that equation like so. And all I did was remove the scientific notation here, so I just turned them into decimals. So when you multiply this together, you should get your impulse. And your impulse is just 968. But since this force is backwards against the momentum of the rugby player, we just need to make this negative. So your change in momentum is change in momentum of the rugby player negative. Well, now all we have to do is calculate the momentum of the rugby player and subtract it from the impulse. And then once you multiply the mass of the rugby player times the velocity, you get 880 kilometers per second. So this is the momentum of the rugby player. And since the impulse is actually greater in magnitude than the momentum of the rugby player, you can expect the rugby player to be going backwards. So the new velocity you're going to get is going to be negative. So all I have to do, let's put these together. So let's add the momentum of the rugby player with the impulse of it. And negative 88 becomes our new momentum of the rugby player, but we want to calculate the final speed. So in order to calculate the final speed, since we have the new momentum of the rugby player, momentum can be calculated by mass times velocity, but we can also calculate velocity by dividing momentum by mass. So once we divide our momentum of the rugby player by his mass, 110 kilos, you get negative 0.8 meters per second. But since it asks for the final speed, all we need to do is just write down the magnitude of the velocity. 0.8 meters per second is our answer. So as always, I need to mention OpenStax. Did I spell that wrong? OpenStax. There you go. I got some of the problems in this video from that online textbook. Link in the description if you want to check it out. I get my curriculum or videos from there, or video ideas. But I need to address something real quick. Someone posted in the comment section, organic chemistry tutor with a personality account. What the fuck? Bro, I'm trying to be as original as I can, but I can't escape this, bro. like 3 of my friends. Oh, just skip this part, by the way. I'm not gonna say anything educational anymore. But 3 of my friends already said that shit, and I was like, bruh. I'm trying to be original. I'm trying to be original, but I can't. Like, I think the main reason why people say that is because I use a black screen instead of like, and like I write on like MS Paint, but like a black screen, I don't have any other option other than a black screen because I tried using a white screen and my eyes were just like killing me when I was making the videos in the nighttime. So I was like, if someone's watching this, then of course your eyes are gonna kill you when you're watching with a white screen. So I thought black screen was a perfect idea. I just spit all over my screen, so I needed to pause the video right there to clean it up. But just to give you a little background, uh, I'm not the organic chemistry tutor, but I am a student as well, and I just wanted to make a channel so then I can help people that were in my situation when I was just taking these classes a couple months ago. But of course, I fact check all the things that I say using not only ChatGPT, I ask TAs and everything like that just to make sure I'm not lying to you guys about everything. And of course, I can't be a hypocrite. I need to get good grades in the classes to be able to teach you guys this. But as always, thanks for watching to the end of this video and listening to my rant for like, I don't know, this is like 1 minute and 40 seconds already. So as always, if you have any questions, put it down in the comment section.